asked to integrate using partial fraction decomposition methods. So we want to rewrite this using partial fraction decomposition. So we want to start by performing the division using long division. And with polynomial long division, you find a number to multiply to this leading term to make it equal this leading term. So that's just 1. 1 times x squared makes x squared. We just have to multiply through. We don't have an x term, so I'm going to put 0x here. And 1 times negative 9 makes negative 9. And then make sure you're subtracting. X squared minus x squared makes nothing. X minus 0x makes x. And negative 8 minus negative 9 makes 1. Okay? So what polynomial long division has done is it said that this integral is the same thing as the result of the division, divide by the divisor, plus the remainder. Okay. So if you tried to use just polynomial long division, you're going to find that u substitution doesn't quite work, because if this is u, we won't be able to get du out of it. So partial fraction decomposition lets you break down this fraction even further. Because look, the first thing you want to recognize is that the denominator can be factored, x minus 3 and x plus 3. And so with, here we gotta probably do this off to the side. What you'll do is you'll take this rational expression and you're going to decompose it into two different rational expressions adding to one another. One with this as the denominator, and you'll notice I put the letter a in the top, and one with this in the denominator and the letter b in the top, because we just have to solve for what constants need to go for a and b in order to make this rational expression be the same as what we're going to rewrite it to be. Okay, so we have this equation to solve, and you'll probably remember from algebra the first thing you want to do, I'm just going to put quotes because it's the same thing, is multiply the top and the bottom by the other fraction's denominator, because that will give us x minus 3, x plus 3. That gives us common denominators with this fraction over here. And then same thing over here, multiply the top and the bottom by x minus 3 this time though. Okay, and so in order to make these equations be true, since the denominators are the same, we just need the numerators to all equal one another. So x plus 1 needs to equal ax plus 3a plus bx minus 3b. And if we collect all the a terms, wait, let me think, I think we're supposed to collect all the x terms. I think that's the best way. So if you factor out an x, you're going to be left with a plus b. So focusing on just these terms, if you pretend they're next to each other, you can factor an x out of them. You've got a plus b left over. Then over here, the constant's 3a minus 3b. So we know a plus b has to equal 1. In order for us to get a coefficient of 1, we know these terms have to add up to be 1. And we know that 3a minus 3b also has to equal 1. 3a minus 3b has to equal 1 in order for these to be the same. So a quick little system of equations problem. You multiply the top by 3. I think that's the best way to go about it. And then add the numerator and the denominator, so you get 6a equals 4. So that means a is going to be 2/3. And then you could plug that back into either equation. We had the first equation before we manipulated was a plus b needs to equal 1. So if a is 2/3, b has to be 1/3, right? So we've got our coefficients, and we're finally done the algebra part of it, where a is 2/3 and b is 1/3. So we said we were decomposing this. We've got it right here. A is 2/3 x minus 3, and b is 1/3. It's x plus 3, then plus that 1. Okay, so now it's just calculus, straightforward calculus, because this, if you want to let that be u, you can factor out the 2/3 from this integral, and that would be 1 over u, right? And so in a previous video, in a lot of the videos this week, we're talking about the integral of 1 over x is natural log. Wait, sorry. Yes, that's natural log x. Because the derivative of natural log was 1 over x we learned from calculus, right? So separating and doing each as their own individual integrals, you can factor out a 2/3 from this first one, and it's 1 over u. So that's going to be natural log u, except I'm doing the replacement all at the same time. And we should have absolute values because x could be negative there. You can't have a positive you can't have a negative value in a logarithm. So same thing here, it's 1/3 natural log x plus 3, that's absolute value symbols, and then this is plus x, an integral of 1, and then plus some constant c. And now we're finally done.